Hey everyone, moving into chapter 10 here, we're dealing with angular momentum. We've dealt with all other rotational components, but now we want to deal with this idea of having momentum when you go in circles. So as the satellites move around the Earth, they are in motion, so anything that has mass and has a velocity must have momentum. But how do we know that it has angular momentum? Before we get into this concept, we got to understand one thing. We need to understand the vector product or the cross product. We did something similar to this before with the dot product, but in this case we're multiplying two vectors together to create a third vector. So taking vector A and crossing it with vector B, that's what the x means, you can find vector C. Or another way to solve for that is do magnitude of A multiplied by the magnitude of B multiplied by the sine of the angle between them, that angle phi. When you do your problems, we'll do a couple examples here to show you how to do a vector product. And when you do a vector product, you will create a third vector this time. So it does not eliminate and become a scalar like we did with dot products. It does multiply together and give you a third vector that you have to deal with, which means that third vector has magnitude and direction. And before we get into cross product, there's something you need to know in terms of how to figure out the direction of your third vector, and it goes back to your right hand rule. With your right hand rule, you want to put your finger or your hand in the direction of the first vector, call it vector A. You curl your hand into the direction of the second vector, vector B, and your thumb is actually going to equal the direction of the cross product, where vector C points. Another way, instead of curling your hands, is to just leave your hands in the IJK format, and you put your pointer finger in that first vector. Here is the curling for the second vector, and again your thumb points in the third direction. So let's go through all those combinations first before we actually do a numeric answer. So in the very first example here, you can see that I have an XYZ plane there on my hands. The X plane, or my middle fingers, point in the I direction. The J direction is vertical, up and down, so that's what my thumb is telling us. And my pointer finger is pointing out towards you, so that is the Z direction, coming out towards you or away from you. So what we want to do is cross each of these vector directions. I with J, J with K, K with I, and see what happens. So let's go through each of the scenarios. Very first one, I'm going to do I cross J. So I'm going to put your fingers in the I direction. I'm going to cross in the J direction, that's curling up, and you can see my thumb now points in the positive K, comes out of the screen. Let's try another one, J cross K. So I'm going to put my fingers in the upwards, the J direction. I'm going to curl them out towards you in the K direction, and that means that my thumb now points in the positive I direction. Let's try K cross I. K is coming out right towards you. The I direction is heading in the horizontal. So if I do K cross I get a positive J. And one way you can think about it is if you look at that wheel I have on the notes here. If I follow around the circle here and go I to J, I cross J will spit out a K. Or if I do J cross K, I'll get an I, and if I do K cross I get J. So as long as you go around that circle, you get the other option. Let's do some other examples here, because these aren't the only three. I could do I cross K. That means fingers in the horizontal direction, curl out towards the page, and my thumb now points down in negative J. Okay, if I do K cross J, that means my hands come out towards you, my fingers are going to curl up in the vertical J direction, and now my thumb points in the opposite direction, so that's negative I. And if I do it one more time, if I do my fingers up in the J direction and I curl in the I direction, now my thumb points in the negative K, away from you, not out of the page, but into the page for your last direction. Or if you take your circle down here in reverse, I cross K spits out negative J, k cross j gives negative I, and j cross I spits out negative k. So some people like the wheel, some people like using the right hand rule and trying to visualize this, but you need to figure out where the vector is going. So a lot of times when you're doing your problems, you'll be curling your hands at your homework trying to figure out which way these vectors are going to go. So unlike last time when we had a dot product, you only dotted things that were the same direction, like i's and i's, j's and j's, k's and k's. But when we do cross products now, I can't curl my hand and I can't curl an I into an I. That means my fingers are in the same plane, or a J into a J. I can't curl, so my thumb never points anywhere. So anytime you see an I cross I, a JJ, or a KK, you can just automatically put a 0. There's no way that those work out. And if you look at how we wrote that out, A cross B equals AB sine of phi. To have a maximum cross product, you have to have the sine of the angle be 90 between the two directions. And if you look at an I and an I, that gives you 0 degrees or 180 degrees between the two directions, which will give you absolutely no cross product. Just like a torque, you need to have things at 90 degrees. We went through the whole thing before, and you can solve these through matrices. I'll allow your calc teacher to show you how to solve these with matrices, but I'm going to show you a couple examples just using this idea of A cross B, or magnitude of A, magnitude of B, sine of phi. Alright, so this is my first example here. Vector A is 4 in the I direction, vector B is 6 in the I and 6 in the J, and I want to know what the vector cross product of these are. So when I do the vector cross product, I'm going to do A cross B. If you look, the 4i and the 6i, I don't care about. I cross I gives you 0. So really all I care about is the 4 times 6 in the I and J direction. So I've got 24, but I have to remember what I cross J is. I cross J is going to give me a positive K. So my final answer is 24 units in the positive K direction, coming out of the screen or out of the page. What I can also then do is ask, what is the angle between vector A and vector B? So what angle are those two separate? Are they close to 90 degrees? They're not 0 degrees because I obviously got an answer. So that means I need the magnitude of A and the magnitude of B. So magnitude of A should be pretty easy. 4 squared, square root of 4 is 4. Magnitude of B is going to be 6 squared plus 6 squared. Square root of that answer ends up being about 8.5. So if I want to solve for the angle between them, then I'm just going to use my vector notation equation. So 24 is A cross B, 4 is the magnitude of A, 8.49 is the magnitude of B. So solving for sine of phi is 0.707. Getting the angle there, you end up with 45 degrees. So that means vector A and vector B are 45 degrees apart. And that's why you can use that rule to solve for the angles. Let's visualize that. Let's see what this actually looks like so that it makes sense that they are 45 degrees apart. So here's vector A, here's vector B. Vector A was just 4 in the x direction, and vector B was 6 in the x direction and 6 in the y direction. So if you look at those two vectors, they are 100% 45 degrees apart. And when you cross vector A with vector B, what you end up getting, we said, was 24 units with a brand new vector in the positive k direction. So right here, vector C is pointing in the positive k or in the z direction out towards you. Let's try a couple other examples to see if you're comfortable with doing vector products. Okay, so I switched it up just a little here. Vector A is still 4i, and vector B is now 6i and 6k. So I want to solve for my answer here. 6i and 4i, we know, cross to nothing. And 6 and 4 again give us 24. But now we have I cross k. I cross k actually gives us a negative j. So really, if I was going to visualize this now, all I did was move one of my vectors. So there's vector A, and now we have vector B, so that means that vector C, negative j direction. So when I cross vector A with vector B, my thumb now points down and allows me to give that negative j direction. Alright, so now I have vector A and B again. One 2i and 3j, and the other one is 3i and 2j. So I want to do my A cross B here and make sure that each multiplication gives me the right direction. So if I do 2 multiplied by 3i and the 2j, well, the I and I cross out to nothing. So really I have to just do 2i multiplied by 2j, which gives me 4k. And then I'm going to do the same thing again, but now I'm going to have 3j multiplied by 3i and 2j. Well, again, I don't have to care about the ones that have the same vector components, so all I really care about is the 3j times 3i. And j cross I gives us negative 9k. So if I want to add up all my answers here, the net result of vector C would be 0 in the I direction, 0 in the j direction, and negative 5 in the k direction. So one last thing we could ask here is, what is the angle between both of these vectors, between vector A and vector B? Let's kind of first visualize where they are. So vector A was 2 in the I direction and 3 in the j direction. So that's 2 over and 3 up. And vector B was 3 over and 2 up. So what I want to do is figure out the angle between those two vectors, between vector A and vector B. So it seems like it's going to be very, very small. And if you look, when I get my answer here, my answer of A cross B ends up giving me negative 5k, which means that my final answer is a vector that points in the negative z direction. It's very hard to draw three-dimensional vectors on a 2D surface, but that green arrow there is vector C pointing in that negative z direction. So let's find the angle between these two. I'm expecting it to be pretty small. So I already know that A cross B is negative 5. Now I need the magnitude of A and the magnitude of B. Well, magnitude of A would be 2 squared plus 3 squared square root, which gives me the square root of 13. And if you look at the components for vector B, it is also 3 and 2 for its two components, just in a different direction. So it actually gives me the same exact magnitude. So if I want to solve for phi, it's the inverse sine of A cross B over the magnitude of A times the magnitude of B. So solving for that, putting in your numbers, you should get an answer around 22.6 degrees. So that is the angle between vector A and vector B using our rules for cross product. The nice thing about doing things with cross product, as you can see from this example, is that your answer key in WebAssign may ask for the I, J, and K components. If everything works out like it did in this problem, that there is no I, J component, zeros are what you're going to put in there, and you're going to get some nice easy points as long as you know how to do your vector cross products. So try some more examples, look at the ones in WebAssign, and have fun taking cross products instead of dot products.